Okay, so now we're ready to start going over our Algebra 1, Chapter 2 content, which is very, very familiar or similar to our Algebra Chapter 1 content. Now, before we were solving equations, now we're going to be solving inequalities. So everything's very similar except for instead of an equal sign, we're now going to have our inequality symbols. And so we have our first inequality symbol, which is the greater than symbol. And then we also have the symbol that looks just like it, but with a line under it. That's the greater than or equal to symbol. And then we have the less than. And then we have the less than or equal to. So the line underneath it is our or equals to. It's kind of like that combination of the equal sign in with the inequality. And so that line is giving us that or equal to idea. And so when we start talking about what is the solution of an inequality, we want to know what value is going to make the inequality true. So when I'm asking, is x equals 3 a solution to the inequality x minus 6 is greater than 4, I plug in the number 3, and I check to see if it's true. So 3 minus 6 gives me negative 3. Is negative 3 greater than 4? And so I have to know what those symbols mean so I can actually decide, is this true or this not? And since I know from the number line that negative 3 is not to the right of 4, that means this is not greater than, and so it's not true or not a solution. So on my next one, is x equals 10 a solution? So I plug in, is 10 minus 6 greater than 4? Well, then I have to ask myself, is 4 greater than 4? And no, it's not. 4 is equal to 4, but it's not greater than 4. So because this is a greater than only symbol, this is not a solution. So then I move on to the next one, is 12. So I plug in, 12 minus 6, is that greater than 4? Well, is 6 greater than 4? Yes, it is. So it's a solution. Now, in an inequality, there's going to be tons of numbers that will be solutions. So we don't just say, oh, yes, this one number is a solution. We start looking at what possible numbers, what all possible numbers are solutions. And so we're going to learn how to write those in an appropriate manner. So go into our last one, 13 minus 6, is that greater than 4? Yep, 7 is greater than 4, so it's a solution. And all my work here is justification on my answer. Why is my answer solution or not a solution? And if I don't have that justification, then I have no way to, or a teacher has no way to establish, do you really understand what's happening here? Or are you just putting out an answer, no solution, solution, and just praying to the heavens that it's correct? So always show your work, justify your answer, so that way if there's something going on, we can help you fix that. Okay, since there are many solutions to an inequality, we can graph all possible solutions on a number line. All of our inequalities can be written in 3 forms. Our first form is algebraically. Algebraically. So I've got my 4 algebraic inequalities written there. And then our next one is in words or verbally. And so when I look at this inequality here, verbally it's saying a number greater than 5. And then we can graphically represent all numbers greater than 5 on a number line. So if I look and I put 5 on here, I have to justify how the number line works. So I have to have a number on each side of 5, so 6 and 4. And when I'm graphing this, I put what we call an open dot on 5, because 5 is not greater than 5. So 5 is not included, but 5.00001 is. So everything up to 5, but not including 5, is included there. So that's why we have that open dot. And then my arrow goes to the right. All numbers bigger than 5. And that is my graph. Now sometimes it's hard to tell one arrow from another arrow. So sometimes we'll actually draw our arrows up above so it's really easy to tell where you're trying to graph. So that arrow is different than your number line arrow, and it's just really easy to see, especially if you write it in pencil. Okay, so our next algebraic inequality is this one. And so we write it out, a number greater than or equal to, because we have the line underneath it, to 5. So now on our number line, we're still looking at the number 5. We still illustrate a number on each side. And then because now 5 is included, because 5 is greater than or equal to 5, now what we're going to have is a closed dot on the number 5. And because I still want all numbers bigger than 5, my arrow is going to go towards all the bigger numbers to the right. And that's how I graph it. So on our next one, we have this inequality. So if we write it out in words or verbally, a number less than 5. So on the number line, we graph our 5. We graph a number on each side. You can always have more numbers, but never less. And then, what type of dot are we going to have on that 5? Well, is 5 included or is it not included? Is 5 less than 5? No, it's not included. So we have an open dot, and we want all numbers lower than or less than that. So my arrow is going to go towards the lower numbers or to the left. Okay, our last one. That's our inequality. And we write it out verbally, a number less than or equal to so number less than or equal to 5. So again, we graph our 5, a number on each side. And because of the or equal to, our dot's going to be closed. And we want all values less than that. So we go to the left. So I want to take a minute and talk about something that's not actually listed on here. And that is the idea of our arrow direction. So in our first example here, our arrow direction is pointing to the right. And you'll find that our symbol is pointing to the right. In our second example, our arrow on the graph is to the right. And our inequality symbol is pointing to the right. In our third example, the arrow is pointing to the left. And so is our inequality symbol. A lot of people use the inequality symbol as a shortcut to figure out which arrow the directions go. So that way they don't really have to think, is it less than, is it greater than? The problem with this is all of these inequalities right here all have what on that left-hand side? And since x is on the left-hand side, that's true. But if we have an inequality that looks like where our x is on the right-hand side, now it's different. And so any inequality where x is on the right-hand side, you can take the entire inequality and you can flip that around. So when I flip that around, the x will go on this side, the 5 will go on this side, and the inequality symbol will flip. And I use the x as kind of a gauge. My inequality symbol is pointing to the x, so when I flip it, it should still point to the x. And once I know how to flip it, then it makes it easy to graph. And I can still use that arrow rule. So just a little hint for you, and something that you're going to have to practice on your assignment tomorrow in class. Okay, So now we're going to go ahead and we're going to write our equations. So now we're going to be looking at our graph, and we're going to write our equation. So when I look at my first graph, my shading is starting right here at the number 3. So I know 3 is going to go in my inequality. I'm going to have x. And my inequality is going to the right. So I know it's going to look like that. Now the question is this an open dot or a closed dot on that 3? And this happens to be a closed dot on the 3. So it's an or equal to. And that's my inequality. Okay, so on the next one, we're starting at the number 2. And then we have an x. The arrow, the shading is going to the left. So my inequality symbol is pointing to the left or to the lower numbers. Now, this is an open dot right here. So because it's an open dot, we do not include the 2, so we do not have an or equal to. Okay, next one. Our number here, negative 0.5. The arrow is going to the right, or the bigger numbers, so it is a greater than. And then this is a closed dot, so I put the or equal to. Okay, next one, our number, it's not actually on the number line, so they wrote it above so you know exactly what the value is, 2.5. The arrow is going to the left or lower numbers. We have our x. And then we have an open dot, so it does not include, so there is no line underneath. It does not include 2.5, so there's no line. Our last one, our value is negative 5.5. The arrow is going to the left, so it's going to be a less than. And to be honest, I can't tell just by looking at it if it is an open dot or a closed dot. Okay, so I pulled out the paper so I could get a closer look at it because it's way more obvious on the paper than it is on my Promethean board, but it is an open dot. So since it's an open dot, we do not have the line underneath it because the negative 5.5 is not included on the graph. Okay. Now we're going to talk about graphing the inequality. I gave you some number lines without numbers, so it is your responsibility to number your number line. So here, I'm going to put negative 5 in the middle because that's the number of my inequality. And then I need a number on each side. You can use 2 numbers on each side because there's spots for them, but you don't have to. So I'm going to go ahead and just label it like this. If I go up 1 on the number line, it's negative 4. If I go down 1 on the number line, it's negative 6. So remember, negative numbers go opposite direction. Now, because this is a less than symbol, not less than or equal to, I have an open dot on my 5. And my arrow is going to go towards the lower numbers or to the left. Okay, for our next one, we're going to start at negative 20 in the center. I'm going to do a number on each side. So as I go up 1, I'm going to have negative 19. As I go down 1, I'm going to have negative 21. Now this is a less than or equal to. So we're going to have a closed dot on that 20 because of that line. And then because it's less than, we're going to go to the left. Now keep in mind, because my arrows are colored, I'm drawing right on the number line. But if you're using a pencil, your arrow needs to go up and over so I can see the direction of your arrow. Because if I can't see the direction of your arrow, I'm going to have to take off points every single time, and it's really just not worth it. Okay, so let's look at the next one. Now we have that X popping up on that right-hand side. So remember how I said we could flip this around? So I'm going to flip the X and the 5. Here, my inequality symbol is pointing to my X. So here, it's going to point towards my X. I go ahead and graph my 5. And I go up 1 to 6, down 1 to 4. Now because there's no line underneath, it's an open dot. And this says X is less than 5. So the arrow is going to go to the lower numbers, or the left for less than. Okay, for our next one, again, X is on the right-hand side. So we're going to flip that around. X and 9. And this time my inequality sign is pointing away from the X. So when I flip it around, it's going to point away from the X. So now I'm going to go ahead and graph. I have 9. I go up 1 to 10. I go down 1 to 8. Because it has a line underneath, it's going to be a closed dot on the 9. And this symbol is greater than, so it goes towards the bigger numbers. Okay, last bit is story problems. Being able to take a story problem and map out what the inequality is for that. And again, we practice the inequalities on their own. So when we're doing these story problems, pay attention. Sometimes I only want you to set up the inequality. I don't want you to actually solve it or graph it. So really, really important for you if you have a hard time with word problems, here's some guidelines. We have no more means less than or equal to. And if you need to, right above it, less than or equal to symbol. Okay, for our next one, at least means greater than or equal to. So that's going to look like greater than or equal to. So we've got 2 sample story problems. Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees Fahrenheit. Define a variable. So what variable are you going to use? I'm going to go ahead and use x equals, and what's x representing? It's representing my temperature. So I'm defining my variable. X is my temperature. It helps if I spell temperature right. And then I'm going to go ahead and say, well, x is at least. And at least means greater than or equal to. So my temperature is greater than or equal to 85 degrees. And there's my inequality. Okay, the next one. A cell phone plan offers free minutes for no more than. So no more than 250 minutes. Define a variable. So I'm going to go ahead, and you can use any letter you want, but I like staying consistent with x, so I'm going to say x is minutes. Because that's what we're measuring. So my x and 250, and then no more means less than or equal to. So less than or equal to 250. And that's my inequality. Okay, so that's it. If you have questions, come to class prepared to ask those before we get started, and I'll see you tomorrow.